Hi guys, here's the video that goes over your test review. So I hope this video helps get you prepared for your test on Friday. So number one says to state the degree and the leading coefficient. So your degree is your highest exponent, and your leading coefficient is a number that's in front of the variable with the highest exponent. So for letter A, your degree is 7, since your highest exponent is 7, and your leading coefficient is a number in front of that, which is -3. Now, please be careful. Don't say your leading coefficient is 8. 8 is in the very front, which is usually where your leading coefficient is, but this particular polynomial is not written in order. So just be careful with that. It is -3. For letter B, your degree is the highest exponent, which is 4, and in this case your leading coefficient is the number in the front, which is 9, since that one is in order. For number 2, it says to use the graph to describe the end behavior, determine if the function is even or odd, and find the number of real zeros. So to describe the end behavior, you always start by writing this: as x approaches infinity, f of x approaches, and as x approaches -infinity, f of x approaches. So then you look at your graph. So as x approaches positive infinity, that's what's happening to the right, you need to see where your graph is going. So as x approaches positive infinity, your graph is going up towards positive infinity. And as x approaches -infinity, your graph on this side is also going up, so that'll also be towards positive infinity. For even or odd, so part B, even means that your ends are going in the same direction. Odd means that your ends are going in opposite directions. So if you look at your ends for this one, they are both going in the same direction, so that is going to make this polynomial even. And then for part C, to find the number of real zeros, you just need to see how many times it crosses that x-axis, which in this case is 4 times. So you have 4 real zeros. And do the same thing for part B. So find the end behavior as x approaches infinity, f of x approaches, as x approaches -infinity, f of x approaches. And then I can look at my graphs. So as my graph moves to the right, my function is going up, so that's towards positive infinity. As I move to the left on the x-axis, my graph is going down towards -infinity. So -infinity. So since my ends are going in opposite directions, that makes this function odd. And then part C, the number of real zeros, just count how many times it crosses the x-axis, and it crosses 3 times, so you have 3 real zeros. Now for the end behavior, if you do not write it exactly like this, with the as x approaches infinity, f of x approaches, all of that, you are not going to get full credit for that end behavior. So do not just write the infinities, write out everything. So that takes care of problems 1 and 2. Let's look at problem number 3. So problem number 3 says to write a polynomial in factored form with the given zeros. So I have a 0 at -8. That means the factor that it came from was x plus 8, because it's always the opposite. The multiplicity is the exponent on the outside, so that'd be x plus 8 quantity squared. And then the 0 at 1 means the factor is x minus 1, with the multiplicity of 3 means your outside exponent is 3. Number 4 asks what the degree of this polynomial is. So if you look at the x plus 8, it's squared, which means you have 2 of those x plus 8s. So I have x plus 8 times another x plus 8. And then x minus 3 cubed, x minus 1 cubed is x minus 1 times x minus 1 times another x minus 1. So if we look at our total number of x's, 1, 2, 3, 4, 5, that'll tell us the degree. So your degree for this is 5. You can also look at the multiplicity. So this x is used twice, so you have 2 x's. This x is used 3 times, so you have 3 x's, which means you would have an x to the 5th. which still gives you that same degree of 5. So there's your answer for number 3. There's your answer for number 4. Alright, let's look at number 5, sketching the graph. So we want to sketch the graph of x cubed minus 10x squared plus 25x. I can go ahead and factor that first. So I can take out the x. That leaves me with x squared minus 10x plus 25. Two numbers that multiply to 25 and add to negative 10. That's negative 5 and negative 5. So I have x, and since it's negative 5 and negative 5, that's the same thing as x minus 5 quantity squared. So we need to find the zeros. I have a 0 at 0 from this one, and then a 0 at positive 5 from that one. So we can go ahead and take those two and plot them. So 0 and 5. Now we can also look at the end behavior. So your degree is 3 with your leading coefficient being 1. So odd degree with a positive leading coefficient means that it is going up to the right and down to the left. So we have those two ends and we just need to connect the zeros logically. So since our exponent for that x minus 5 is even, that means at that 5 it is going to bounce. So at the 5 it should bounce. So your curve's going to look something like that, and then it's going to go through at that 0. So your graph looks something like that. Hopefully your graph looks a lot better than mine. Now another way that you can do this is to graph it on the calculator to get a shape. So let's look at the calculator. So in the calculator I'm going to go to y equals, and I'm going to type in x cubed, so x to the third, minus 10x squared plus 25x. Now in the calculators in the classroom you would see this 3 as an exponent, but it does mean the same thing with that little caret and then the 3. So let's go ahead and hit graph. And you can see through the calculator that it does cross at 0, 0, although it's very, very steep, and then it bounces at 5. So you can use the calculators to get a general shape for the polynomial. Now it does say to label the max and min. So this right here is a max since it's a top hump, and that is a min since it's a bottom hump. So there is number 5. Alright, let's look at number 6. So number 6 is the average rate of change. So the price P of one share in a company at any time t years can be modeled by the function P of t equals negative 0.2 t cubed plus 2t squared plus 8t plus 2. Find the average rate of change over the interval from 7 to 9. So we need to start by finding P of 7 first. So you're going to take 7 and plug it in for t. So just replacing all of my t's with 7s. I'm going to put that in my calculator. So negative 0.2 times 7 to the third plus 2 times 7 squared plus 8 times 7 plus 2. That gives you 87.4. Also going to find P of 9. I obviously did not give myself very much space for this, but negative 0.2 times 9 to the third plus 2 times 9 squared plus 8 times 9 plus 2. I'm going to take that and plug it in. And that gives me 90.2. Okay, now to actually find the rate of change, which I'll do in blue, you're going to take your second one. So 90.2 minus your first one, which is 87.4, divided by your interval, so 9 to 7. So let's calculate that. So 90.2 minus 87.4 over 9 minus 7 gives me 1.4. Now, to be able to interpret your answer in the context of this problem, we need to understand our units for this. So it says the purchase price was P, so purchase price is in dollars, so that means in the numerator, what we evaluated, those were dollars, so dollars up here, and then the 9 to 7, or the 7 to 9, was the time in years, so down here is years. So that means our purchase price increased by $1.40, because this is in dollars per year. So it increased by $1.40 over the course of those 2 years. So to answer letter B, we would say the purchase price increased, since it is positive, by $1.40 each year from year 7 to 9. Okay, so it's only from those 2 years where it increased by $1.40. If we had a different interval, like 1 to 4 or 12 to 15, the increase might be different. Okay, but it's just for those, that interval from 7 to 9 where our rate of change is 1.4, so it increases by $1.40 for each of those years. Alright, so let's look at number 7. So 7, we are using the table to find average rate of change. So a new bacterial spray is tested on a bacterial culture. The table shows the population P of the bacterial culture T minutes after the spray is applied. Find the average rate of change from the interval 0 to 3. So 0 to 3. So I'm going to do the 737 first minus the 800 over 3 minus 0. That gives me, calculate it, 737 minus 800 over 3, which is negative 21. Now it's negative because our number of bacteria is decreasing. So if you look at the time of 0, we had 800, and then after 3 minutes, we had 737. So your rate of change is negative. Now let's look at the interval from 4 to 7. So looking at these. So I have 37 minus 652 over 7 minus 4. So 37 minus 652 over 7 minus 4, which gives us negative 205. Okay, so compare your answers in part A and B in the context of the problem. So as time increases, more bacteria are getting killed by the antibacterial spray. So from 0 to 3 minutes, they only killed 21 bacteria, and then from 4 to 7 minutes, they killed 205 bacteria. So as time increases, the rate at which the bacteria dies also increases. Okay, because that negative 21 means that they killed off 21 bacteria over the course of those 3 minutes, and then the negative 205 means that they killed off 205 bacteria over the course of those 3 minutes. So as time increases, the rate at which the bacteria dies also increases. Alright, so let's look at number 8. Okay, so number 8 is the graphing calculator problem. So we'll go back to the graphing calculator. We are going to type this in exactly how it looks. So I did that wrong. That should be a negative instead of a minus. So negative 0.00104 x to the 4th. I forgot the little caret key. X to the 4th plus, what is happening here? change that to a plus. So plus 0.0615 x to the third. And of course it's going to look different when you plug it into the other calculators because this one is not fully updated. Minus 1.247 x squared plus 9.693 x minus 13.875. Now let's graph that. Right now we're in the standard viewing window, so we do need to change it because you obviously can't see the entire graph. So we need to adjust the window so that it matches what we have on the grid that I gave you in this review. So we can adjust the window so that x-axis starts at 0 and goes to 33. The x scale will stay as 1. The y min goes from -4, because your y-axis goes to -4, and up to 16. So then you can go ahead and hit graph, and now you should be able to see the entire graph of the function. So the first thing that we're going to find is this 0 over here. So we'll find the zeros first. The zeros are the same thing as the x-intercepts. So I'm going to start by hitting second trace. I'm going to select number 2, 0. And then left bound, I'm going to pick a left tick mark to the left of that 0. So I'm going to go with 1, since 1 was on the left side, and 6, since 6 is on the right. Hit enter, ignore where it says guess, and then hit enter again. So that 0 is at 1.8, comma 0. So I'll write this 1.8, comma 0. Let's go ahead and find the other x-intercept. So I'm going to do the same thing. So I'm going to hit second trace, go to number 2, 0. Now this x-intercept is all the way over here. I'm just going to estimate. The middle is about 15, so I'm going to put 15 for my left bound. And I know I went all the way to 33, so I'm going to go ahead and use 30 as my right bound. Always ignore where it says guess and then hit enter again. So that 0 is at 26.2, and that E always means 0, so the y coordinate is 0. So let's go ahead and write that down. It was 26.2, comma 0. So now that we have our x-intercepts, or the zeros, we can go ahead and find the max and mins. So I'm going to go back to my calculator. Whoops. Okay, so the maximum is a top hump, the minimum is a bottom hump. So I'm going to start by finding this first maximum. So I'm going to hit second trace, go to number 4 maximum, and then hit enter. So this one you're actually going to move the cursor all the way over to the left side of the hump that you are trying to find. So I'm going to move this over all the way to the left. So as you can see, my cursor is on the left side of that hump. I'm going to go ahead and hit enter, and then I'm going to move the cursor so that it's on the right side of the hump, and then hit enter, enter again. So that's at 6.7 and 11.5. So I'm going to add that to my points. So 6.7 and 11.5 for the first max. I'm going to go ahead and find the second max. So I'm going to do the same thing, hit second, and then trace, go to number 4 maximum, and I'm going to find my next maximum by moving over to the left side of that hump, hit enter. I'm going to move over to the right side of the hump, hit enter, enter again. So that's at 21.5 and 7.1, since we'll round to the nearest tenth. So 21.5 and 7.1. Last thing we need to find is the minimum. So I'm going to go back to my graphing calculator. Going to hit second trace, number 3 minimum. So now I'm going to move to the left side of the bottom hump, hit enter, move to the right side of the bottom hump, hit enter, enter again. and that is at 16.1 and 5.7. So 16.1 and 5.7. Okay, now that we have all 5 of those points, we can go ahead and graph them. We always want to label the axes. So that horizontal axis, the x-axis, was the horizontal distance. So horizontal distance, and that was in thousands of feet, right? Yes, no, hundreds of feet. Hundreds of feet, that's what it says right here, horizontal distance in hundreds of feet. And then the y-axis is the height in thousands of feet, so this is the height. Oops. Height. How do you spell height? Height. Sorry about that. In thousands. Sorry about my terrible handwriting. Thousands of feet. Okay, so let's go ahead and graph it. So my first x-intercept is at 1.80. So there's 1.80. The second one is at 26.2. So 2, 4, let's count. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26.2. There it is. And then maximum is at 6.7 and 11.5. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11.5. And then 21.5 with 7.1. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 21.5, 7.1, 1, 2, 3, 4, 5, 6, 7. So about right there. And then the minimum's at 16.1 and 5.7. So 2, 4, 6, 8, 10, 12, 14, 16, 5.7. 1, 2, 3, 4, 5.7. So about right there. And then we can just connect the dots and make your curve. Let's go ahead and label it. This was the x-intercept. This was the x-intercept. This was max, max, and min. All right, so I hope all of that helps you get prepared for your test on Friday. Don't forget, all of the answer keys are posted on Canvas. All right, see you on Friday.